Look at the board. That next topic, Tuesday's topic, balancing of chemical equation. What do you mean by this? Balancing means having same number of atoms on left and right side. For example, in this reaction, how many atoms of carbon do we have on left side? One. Fine. Two oxygens. Two oxygen. So everything is okay. So this is a balanced equation. Why? Because there are as many as carbon on the left as there are on the right side. As many as oxygen on the left. If it's not, for example, I'm writing here N2 plus H2 arrow NH3. Here we can see how many nitrogens? 2. Here how many nitrogen? 1. Unbalanced. How many hydrogens? 2. How many hydrogens? 3. Unbalanced. So the process of balancing, the process of equating, we'll study on Tuesday, in which we'll see different equations like you can see on the screen that our correct chemical equation must be balanced, means the number of atoms of each element on left and right side must be same. If it is not, we should do it, and the process is called balancing a chemical equation, and the method is called error and trial method. Now, today's topic, balancing of chemical equation, it will be a board work. Let me start. All right, so let's begin. See, H2SO4 is the formula of sulfuric acid. Very good. Sulfuric acid. Now, if I ask how many hydrogens are here, you will see the subscript, which is 2. So your answer would be 2. So how many hydrogens it has? 2. How many hydrogens it has? 2. How many sulfurs do we have? Just 1. No subscript written over here. Now it will be your general chemistry that sulfur and oxygen both are different. It's not like this. No, these are two different. This should not be written like this. Sulfur, and if it is oxygen, it should be of the same height. Okay, sulfur and oxygen, these are two different elements, should be of the same height. Similarly, if I want to write here carbon dioxide, then I shouldn't write like this or like this. The height of carbon and oxygen should be same. So how many sulfurs do we have? 1. How many oxygens we have? 4. Simple. So I have written a formula of sulfuric acid. It contains 2 hydrogens, 1 sulfur, and 4 oxygens. Right? Now, suppose I have 3 molecules of H2SO4. I have 3 molecules of H2SO4. Then instead of writing in this long form, I'll write in a condensed form, like in algebra. Remember, X plus x plus x. How many of you remember x plus x means 3x. Y plus y is equal to 2y. I'm as good in maths as I am in chemistry or physics. All right? So instead of writing these in this long form, we'll write very technically, very cleverly over here H2SO4 three molecules. The detailed form, the condensed form, the short form. The meaning of both of these is same. Three molecules of sulfuric acid. Three molecules of sulfuric acid. Okay? Now if I ask, how many hydrogens are here? So you will use your mathematical chemical sense to 2 or 3 to the 6. So what is the main point here? That whenever it is asked that how many atoms are there, you should have to multiply the subscript by the coefficient. So 3 to the 6 hydrogens. If I ask how many sulfurs, what is the value here? 1. So 3 ones are 3. There should be 3 sulfurs. And how many oxygens? 3 fours are 12. 12 oxygens. 4, 4, 4. 12. Okay? Now see a quick example. If I write here carbon dioxide, how many molecules? 1 molecules. If I write here 5 carbons, 5 CO2, and I ask, how many carbons do we have? You said 5 carbons. How many oxygens do we have? 5 to the 10. See another example. C6H12O6 is the chemical formula of glucose. Chemical formula, molecular formula of glucose. How many of you still remember what would be its empirical formula? Is asking. Yes, cut it by 6. Empirical formula means simplified formula. So you can simplify it by 6, 6 to the 6, 6 to the 12, 6 1 to 6. Recall your memories. So that would be the empirical formula. If it's not, you should revise. Okay, come back to the topic again. So it's a single molecule of glucose. If someone asks how many carbon it has, 6 carbons, 12 hydrogens, 6 oxygens, fine. But instead of this, if we have 2 molecules written as a coefficient over here, 2 molecules of glucose. Now if I ask that how many carbons are there, you should multiply 2 by its subscript. So 2 6 are 12. How many hydrogen it has? I'll multiply 2 by 12. And how many oxygen we have? 2 6 are 12. All right? Clear? On this point, the whole topic, the next topic, the upcoming topic is based. If you won't be able to understand it, next topic will be in air. Okay? One more example, or two more examples, then we'll start the next. The next, uh, two different topics. A quick, smaller one first. C2H8. C2H6. And I'm writing here 4. How many carbons it has? What is that? 8. How many hydrogen it has? The simple part is over. Check it again. I'll start it after a minute, after about some seconds. Go through. Starting from here. 1 molecule of sulfuric acid, 2 hydrogens, 1 sulfur, 3 molecules. Just write it in condensed form. How many hydrogens? 3, 2s are 6, 3, 1s are 3, 3, 4s are 12. Okay? Silent revision. All right. See the next one. Just try to say its name over here. What could be its name? Aluminium sulfate. Aluminium sulfate. If I ask how many aluminiums right now is here, your answer is very simple too. How many sulfurs? Recall the topic to find the molar masses. This number should be multiplied by this. 3, 1s are 3. How many oxygens? 3, 4s are 12. I told you earlier, science grows vertically. Whatever you know today, next will depend on it, on it, on it. If you remember how to find atomic masses, molar masses, formula masses, chemical, then will be difficult for you. Okay? So aluminum sulfate, Al2SO4 3. 2 aluminiums, 3 sulfurs, 3 4s are 12. Now make it little bit harder. Al2SO3, and I'm writing here what? 3. The thing has become complicated. Okay, but you are intelligent enough, you can do it. Say in your mind, how many aluminiums? 3, 2s are 6, Now the next is sulfur. Now sulfur is inside the bracket, so this 3 is multiplied and this 3 is also multiplied by this subscript. What is the subscript here? 1. So look at the board. 3, 1's are 3 and 3 3's are 9. Oxygen. You know these two are multiplying, right? And this one is also multiplying. So 3, 4 and this 3 will multiply with each other. So what would be the answer? 3 4's are 12, 3's are 36. So how many oxygen it has? 36 oxygens. Repeating. 3 2's are 6 aluminium. Sulfur is inside the bracket. So not only this 3 multiplied, but also this 3. So 3 over 3, 3 3's are 9. Oxygen is 4, 3 4's are 12, 12 3's are 36. Okay? One more example, then we'll start our proper class. Suppose it's a 10. Ca2HPO4, or rather it's 3. Its name is, or take a different one, the easy one. Calcium bicarbonate. At this point, 1 calcium, 2 hydrogens, 2 carbons, but 2 3 6 oxygens. Okay? Okay, I'm writing calcium 1, hydrogen 1, hydrogen 2, carbon 2, and oxygen 6. But if it's like this, then there will be 4 calciums, hydrogens. How many hydrogens? What is the subscript here? 1. 4 1's are 4 and 2's are 8. How many carbons? 4 1's are 4 and 4 2's are 8. Carbon inside the bracket, so this 2 is multiplying over here and this 4 is also. 2 1's are 2 and 4, 2 4's are 8. Now oxygen. 2 3's are 6. 6 4's are 24. If you understand it around 60 to 70%, it's okay. It's okay. No problem at all. When you practice it, then this 60 to 70% will convert into 100%. Okay? So practice it. You can write your own formulas and show it to me. For example, you can write, sir, I am right. What is this right? I did hydrogen this much, nitrogen this much, oxygen this much, and send it to me. I'll let you know that you have done it correctly or incorrectly. So what is the only thing which is left is the practice. Okay, so with this information we are starting our topic. So what is the today's topic? Balancing of chemical equation by error and trial method. As I told you, the topic would be continued tomorrow. Okay, suppose you have got an equation. All right. So how many of you can answer that how many carbons are there on the left side? How many carbons on the left side? One. One. Okay. You can even write over here as you can see in the book. Okay. So how many carbons? One carbon, one carbon. Carbon is balanced. Why am I calling it a balance? Because it contains same number of atoms on left side and right side. One carbon, done. What is next? Oxygen. How many oxygens can you see over here? We have just done it 2. The subscript here 2. And here we have only 1 oxygen. So the number of oxygens are unbalanced. Never write in the question. Rewrite the question again. And then with the help of pencil, try to balance it. Let's suppose it's a pencil. So if I say here 2 oxygen, one most important point. To balance an equation, whenever you want to write by yourself a coefficient, never write over here. You can only write over here as coefficient, not subscript. I repeat, suppose it's a formula and due to some reason you are asked, you are willing to write a number over here to balance sulfur, let's suppose. Suppose you want to make, here we have only 1 sulfur, suppose you want to make it 4 sulfurs. Then do not write sulfur over 4 over here, it will be wrong. You can only write as a coefficient. It will say 4 sulfur. 4 sulfur. Obviously the values for hydrogen and oxygen must be changed. So what is the most important point? You are not going to write anything, any number as subscript, but as a coefficient. So how many oxygens we have? 2 oxygens. Now we on right side it's 1. We want to make it 2. So if I write it here, it will be wrong. That's why I write here 2 with pencil. 2 oxygens. Now it has 2 oxygen. Oxygens are balanced. Okay. But due to this 2, carbon has become unbalanced. Here we have now 2 carbons because we have just studied that whatever number is written as a coefficient over here, it will cover all the atoms. So this 2 is not only for oxygen but also for carbon. So how many carbons do we have? 2. So here we should write 2. Now it's balanced. 2 carbons, 2 carbons, 2 oxygens, 2 oxygens. Okay. Now carbons 2, oxygen 2. Here carbon 2, oxygen 2. But here the case was different. Here we have 1 carbon, and two oxygens, one carbon and one oxygen. Carbon was balanced, oxygen wasn't, so we have balanced both. See the second example. A very famous example, H2 plus O2, H2O. Hydrogen and oxygen are combining together forming water molecule. We are not supposed to write it in the question. So we'll write the question again. Take a pencil in your hand. Now, what is the situation? What is the situation? If you are comfortable, then there is no need to write this part. If not, you can show it like this. Now, before balancing, there are two hydrogens and two oxygens. Here we have two hydrogens and one oxygen. This is the current situation. Now we want to balance it. We can see that hydrogens are balanced, but oxygen isn't. Here we have two oxygens, here we have one oxygen. So we are trying to balance this H2 plus O2, H2O. Okay. We'll balance with the help of a pencil. It will be better. Two hydrogen fine. Hydrogen is balanced. Two oxygens, one oxygen. So oxygen unbalanced, we'll write 2 over here. Now two oxygens, two oxygens. But due to this, number of hydrogen has been changed. Here we have two hydrogens, here we have 2 to the 4 hydrogens. So we should write a 2 over here. Now everything is settled. We have hydrogen here, 2 to the 4. We have two oxygens. We have 2 to the 4. And this 2 is also for this oxygen. Last example. Sodium plus chlorine, NaCl. Second last example you can say. I do it in a little bit quicker way. One sodium fine. Two chlorines, one chlorine. So what will we do? To balance, we'll write 2 over here. Now two chlorines. But the sodium has been changed. Okay. Last example. C plus O2. Carbon 1. Two oxygens.